Let's explore coordination covalent bonds, also known as dative bonds, and understand how they differ from regular covalent bonds. A coordination covalent bond forms when one atom donates both electrons in a shared pair to another atom. First, let's understand what makes coordination bonds special. In a coordination covalent bond, both shared electrons originate from a single atom, unlike normal covalent bonds where each atom contributes one electron. These bonds are also known as dative bonds or coordinate bonds in chemistry. The atom providing electrons is called the donor or Lewis base, while the atom receiving them is the acceptor or Lewis acid. The donor atom must have a lone pair of electrons, while the acceptor must have an empty orbital to receive them. Let's compare coordination bonds with regular covalent bonds. In a normal covalent bond, each atom contributes one electron, shown here with different colors. In a coordinate bond, both electrons come from the same atom. However, once the coordinate bond is formed, it becomes identical to a regular covalent bond in strength and properties. What conditions must be met for a coordination bond to form? 3 things are needed: a donor atom with a lone pair of electrons, an acceptor atom with an empty orbital, and proper geometry for overlap. Common donor atoms include nitrogen, oxygen, and sulfur, which have lone pairs of electrons available. Common acceptors include hydrogen ions, transition metal ions, and boron, which have empty orbitals. Let's examine the formation of the ammonium ion as a classic example. Ammonia has a lone pair of electrons on the nitrogen atom and 3 hydrogen atoms bonded normally. When ammonia reacts with a hydrogen ion, the nitrogen's lone pair forms a coordinate bond with the empty orbital of the hydrogen ion. The result is the ammonium ion, where all 4 bonds appear identical even though one formed differently from the others. In the ammonium ion, all 4 nitrogen-hydrogen bonds are completely equivalent in every way, despite their different origins. How do we represent coordinate bonds in chemical structures? Coordinate bonds can be shown with an arrow pointing from donor to acceptor, a regular dash, or sometimes a reverse arrow. The arrow notation is particularly useful because it shows the direction of electron donation from the lone pair donor. Coordinate bonds appear in many important chemical compounds. Examples include the ammonium ion, hydronium ion, metal complex ions, and even hemoglobin in your blood. In metal complexes like copper tetraamine, 4 ammonia molecules donate lone pairs to the central copper ion through coordinate bonds. Let's look at how coordinate bonds affect molecular properties. Once formed, coordinate bonds have the same strength and length as equivalent normal covalent bonds. They create stable coordination complexes with metal ions, which is crucial in many biological and industrial processes. A typical coordination complex has a central metal ion surrounded by ligands, all connected through coordinate bonds. Let's recap the key points about coordination covalent bonds. In a coordination bond, both shared electrons originate from a single donor atom rather than one from each atom. Formation requires an atom with a lone pair to donate and an atom with an empty orbital to accept the electrons. After formation, coordinate bonds are completely indistinguishable from normal covalent bonds in strength and behavior. These bonds play crucial roles in coordination chemistry, acid-base reactions, and biological molecules like hemoglobin.